Math 2 students, this should be a pretty quick lesson. This is your PDF for today, 264, and we already did this part right here, so you can mark this part out. Instead of me trying to put a square over it and it still being there, just want to tell you to mark that part out. Also remember, these notes go along with the Edpuzzle video, so if you're listening to me on the Edpuzzle video, you should also have your, have your notes out, so you can do those, you can print them, or you can do them on notebook paper or the PDF itself. But don't try to do the video without doing the PDF, and vice versa. So we are talking about systems of equations, nonlinear systems. And what that means is a system of equations is more than one equation put together on a graph. So you might have a parabola and a line together on a graph, or you might have a parabola and an absolute value function, which is a Math 3 term, so don't worry about that. But you could have two lines on a graph. And if you remember, let me get a new sheet here to show you. If you remember from Math 1, you did systems of equations where you might have two lines that you graphed, and maybe you did them by hand, and what you were looking for is where they cross, where they intersect each other. That is the solution to a linear system of equations. Just one point. The only time there wouldn't be a solution is if they were parallel to each other, if they never crossed. That's the only thing I can think of, because these are on the same plane. If they're on the same coordinate plane, then they're in the same plane. So the only time you wouldn't have a solution is if they were parallel, and all the other times they would always have one solution. So you might remember that from Math 1. Now, in Math 2, we are looking at systems of equations where one of them is a quadratic, so it's a parabola, and the other one is a straight line, so it's linear. So we have a linear equation and a quadratic equation. A linear equation makes a straight line. A quadratic equation makes a parabola. So there are some different situations that you might run into. There are actually three different situations you might have. So, and you don't have to write all this down. You can if you want to somewhere on your notes, but you don't have to. So let's say you had a line right here, and then you had a parabola that goes like this. You have 2 points where they cross, and that is the solution to this type of system also. So there is a possibility where you would have two solutions. This is the most common. This is what we see the most often. But there could also be a situation where you have this parabola over here, and then your line is way over here. In this case, they don't ever cross each other, so there is no point at all that they have in common. That's what we're really looking for. What points do they have in common? What situation are both of these equations true, basically? So in this situation, there would be no solution. So you would answer it that way. And then very rarely, what you might see is a parabola and then a line that just kind of touches the parabola, and that's really, it looks like more than 1 point, but it's really just 1 point. A line that touches a parabola, or a line that touches anything at 1 point, any sort of nonlinear curved graph, whether it's a circle or whether it's a parabola or whatever, a line that touches it at 1 point. This is called a tangent line. I'm going to write that. You don't have to remember that word. You will need to know it for Math 3. So this is a tangent line because it touches that parabola at 1 point. So this one would have, this situation would have one solution. Okay, so what you would do for the solutions most of the time is you would just list the ordered pairs. So whatever the ordered pairs are. Sometimes it only asks you for the x value. All right, let's look at some examples. And you know throughout this there are going to be some problems for you to look at as well. So there are algebraic, and when I say algebraic, I mean solving by hand, solving on paper. There are algebraic ways to solve these systems. You've done them. You've done them in Math 1. You should have done them in 8th grade math. We do systems in 8th grade math. They're linear systems, they're lines, but you've done them, and I'm going to tell you again, just like I've told you before, if you have Desmos in front of you, which we do on our exam, there is no reason to waste time trying to do them algebraically. And it's saying, solve the following system of equations graphically. What that means is we can go to Desmos and graph this system of equations. So there are two different equations, so you just go over to Desmos. And let me get rid of these. I've got all of them graphed here. So the two equations for number 1, I think it's number 1, for the first problem, are this top line and the second line. And so I'm just going to click these two circles and make them visible. So I've done that, and then what I'm looking for again is the points of intersection where they cross each other. So this one has 2 points of intersection. Sometimes you're asked that question. Sometimes you're asked, how many solutions are there? So just be careful to pay attention what you're being asked. If you're asked, how many solutions are there? Then look how many points of intersection there are. This one, it's 2. If you're asked for the actual solution set, or let me see, what does it say? Solve the following system for all values of x and y. Then you're looking for the ordered pairs. So let's go back over here, and I'm going to make this visible here. So this is that same graph, and I have the ordered pairs marked. So this one has 2 solutions, and they are at -4, 5, and 1, 0. That's it. 2 solutions, and those are the ordered pairs where the solutions are. And that's all we're going to do with these. The next one is another graph, and again, I did graph it on Desmos, but I'm going to make it so it's visible here. Make it as big as I can. It's a skinny graph. Okay, it's asking for us to solve the system of equations graphically for all values of x and y. What that means is, what are the ordered pairs that are in this solution? -1, 8, and 5, -4. That is it. If it asked you how many solutions there are 2. 2 points of intersection. The next one says solve the following systems algebraically. We are not going to do that. Like I said, we're going to do all of these graphically because it's easier, and we have Desmos at our disposal. 2 solutions. If it asks you how many solutions, there's 2. Again, the 1 and 0, the 0 is not quite as rare as the 1, but you rarely see a tangent line here. Let's see, what are they? -6, -11. And 2, -3. And then our last one, I am going to look at this one, but I'm going to go back over to Desmos and show you something, give you another kind of preview of Math 3. Okay, so again, 2 solutions. That's really just the most common thing you're going to see. And it asks for us to solve it for all values of x and y. And 3, 7. And that's the end of this particular lesson, but I do want to show you something else. I don't know if you remember, but you should have done some inequalities again in 8th grade. And an inequality, like, let me take this line. So this linear equation, this is y equals x minus 1, okay? If I change the equals to, and I'm going to go down here and find my less than or equal. If I changed it to less than or equal, then there would be part of this graph that is shaded as opposed to being just the line. So then it would be all the x values over here in this blue part. So it would just shade everything. I can, if you're on Desmos and you want, you can like change your colors and stuff if you want to. Change them whatever you want them to be. So this is just a linear inequality. That's what this is called. If I wanted a system of inequalities, I could change, okay, so one of them can be less than or equal to, and then I'm going to make this one greater than. I'm just going to make it greater than. Okay, so let's see what happens here. Okay, I'm going to change the color of this to make it a little bit easier to see. I'm going to change it to black. Okay, so what I'm looking for here, and you can see also that this parabola is a dotted line. The reason it's a dotted line is because I made this greater than and not greater than or equal to. The solid line on the orange is because it's less than or equal to. Okay, so what I'm looking for here is I'm looking for everything, if this is a system of equations, I'm looking for everything that is, give me 1 second because I want to make this so I can draw on that graph. Okay. So if I'm doing a system of inequalities, which is what this would be called, okay, this would be a system of inequalities, and I'm probably not going to test you on this, except I might ask something like, you know, why is the line dotted? Why is the black line dotted and the orange one isn't, or something like that. I'm not going to test you too much on this because, again, this is kind of a preview of Math 3, but I did want to show it to you. So this is a system of inequalities. So the orange part is my line right here, okay? And then the black part or the gray part is this parabola. But the solution to this system of inequalities is everything that is both black and orange. So again, it is where they intersect, but it's a shaded region. So it's all of this stuff in here, as opposed to just being 2 points, it's this whole region in here, okay? So this is something that, again, you're going to see it next year, and I want you to kind of recognize it when you see it. Another thing we do in Math 3, and I'm going to make these so they're not visible anymore. Hang on. We might do, let me go down here to this one. I'm going to get rid of that ink. Okay, make this one visible. This is called an absolute value function. So if I did this function, and let me see what this one looked like again. No, I don't want that one. I'm going to make this, if I make this a negative, it'll open down. Oh, and they don't touch. Look at that. There's no solution for those because they don't even touch each other. Let me see if I can bring this one down. Let's do a -10. Bring this one up some. There we go. Okay. So in this case, there is an absolute value function right here, and then your quadratic functions right here. So then if I change this to less than the blue, okay, that's that, and then greater than the red, it would be everything that is both blue and red. So it really should be purple, but it's not. So both of the blue and the red right here in the middle would be the solution set to that inequality. And I'm not going to get into how we denote that or anything like that. It's just that that's what it's showing right there. Okay, what else was I going to... Again, if I put greater than or equal to, now if I change these around and I change that one to less than, and then I change the red one to greater than, that's a really weird solution set because it's this part out here. Okay, so it's kind of this purple part. What if I change this one also to less than? Well, then you've got this part down here. So it really just depends on whether it's less than or greater than. You're looking for the part where the colors kind of coincide. Okay, so that's systems of inequalities. That's what that looks like. But we did nonlinear systems where we just had equations, and so they would have just points where they intersect. So that's really what this lesson was about, was those points where they intersect. All right, and that's it. That was less than 15 minutes video. And if you come into the live meeting today, I can answer any questions you might have about this, and you can get your extra credit.